Okay, today we're going to talk about epoxy and the epoxy mixes we use for assembling the HP-24 sailplane. We use epoxy to both laminate and saturate fiberglass, carbon fiber, and Kevlar. We also use epoxy to make bonding pastes that we use to basically glue together the parts of the glider. But first we're going to talk about epoxy and personal safety. Rule 0 of handling epoxy is never ever let epoxy, either the hardener or the resin, touch your bare skin. If you ever do have a contact with epoxy resin in your bare skin, down tools immediately and saturate a paper towel with ordinary household vinegar and wipe off the affected area with vinegar. First, gloves. Whenever you are working with epoxy for laminating or bonding operations, you'll want to wear gloves. We use nitrile gloves like this, whatever color or size fits you. I also wear cotton inspection gloves underneath my plastic gloves because they help separate my skin from the membrane of the glove, and they also help soak up sweat so my hands don't get so sticky during an operation. In the shop, I often wear an apron like this. Thrift store wear, barbecue aprons are really good for it. It helps protect your shop clothing from epoxy drips and splashes. You can see I'm also wearing scrubs from the local thrift store. We found that scrubs are convenient because they fit over your street clothing and they're easy to wash, they're nice and rugged. And here are my sleeves. I've got long sleeves to protect my bare arms from epoxy splashes. And I like flannel for a shop shirt because in case the shop is kind of cold, and the thick fabric also helps protect my skin from epoxy resin that might drip on them. For big jobs in our shop, we use these disposable Tyvek suits. They last about a dozen wearings before they get too ratty to wear anymore and the seams start to split. Here's a pro tip for these suits. On the sleeve, if you cut a hole or a slot for your thumb, you can keep the sleeve from slipping out and exposing your wrist. So this makes it easier to cover your wrist with the end of your plastic gloves. When we're working in enclosed environments, like in a heated shop, we'll often wear NIOSH type organic solvent respirators like this because they better protect us from the vapors that might come off of the laminating epoxy. When we're mixing epoxy bonding pastes, we'll wear particulate masks. What we're going to do next is mix up some epoxy bonding paste, and we're going to glue in the hinge saddles there and there in this left side rudder skin for the HP-24 kit sailplane. Okay, for mixing epoxy, we mix epoxy by weight. We have this scale and some others like it. They're like 1 or 1.2 kilogram scales from eBay or Amazon. We keep our scales wrapped in plastic bags so that the epoxy doesn't drip into the mechanism and corrupt them. So I'm going to start mixing a batch of epoxy here. First thing I do, take my cup, set on the scale, and the scale goes to, right now it's reading 6.9 grams. And we do work in grams in this shop, even though we also use inches and feet and stuff like that. Grams just turns out to be a really handy number for epoxy because they're decimal and because the numbers work out easily. So I'm going to zero my scale so I can tear out the weight of the cup so I don't mistakenly add the cup into the mass of the epoxy that I'm about to mix. Okay, so for this mix I'm looking for about 20 grams mixed. I'm going to multiply that by 0.8 and I think get like 16 grams or so, and I'm going to make up the rest of the weight with the epoxy hardener. 16.6, right around there, so I'm going to go 16.6, and then I hit plus, and then 22, because our mix is 22 parts per 100, plus 22, and then I hit the percent key right there, and it says my mix is supposed to be 20.252 grams of total resin plus hardener. So now I'm looking for 20.2 grams. I've got a quart can here, and I'm going to shoot for that. Okay, so I poured out some epoxy resin, and then I've added 22% hardener to it, and now I've got a little cup with about 22 grams of epoxy resin plus hardener. Next step is to mix it up so the two parts are thoroughly mixed together. Start by mixing what's in the bottom, and not so important for a little mix like this, but you also want to make sure that you carefully scrape the sides of the container anywhere where it's been exposed to just the raw hardener or the raw resin, and that ensures that you get every little bit of the unmixed portion down into the bottom of the cup where you can mix them two together. With epoxy resin, unlike some other structural resins, it's very important that both parts be thoroughly mixed together, and you should be careful to not use any portion that you think is improperly mixed. We'll say what we can. We're getting a bunch of good footage here. Rand's going to do a great job cutting this into an instructional video. Hi, Rand. Are you still filming?
I thought you'd enjoy hearing that.
Okay, so I've mixed our epoxy resin, the resin plus hardener together. Now I'm going to mix some fillers into it, like flocked cotton fibers and also some cabocil. That's the trade name for fumed silica. And I'm going to turn this epoxy resin into a thickened paste that will stay where we put it and has a lot of strength to glue our parts together. So I think that's, I'm going to just start by mixing Flox in by eye and by experience. I'm going to put a bunch in, and I'm going to start mixing it together, and you can see it sort of balls up. And then you mix it all in, and you can see there I've turned it into something with kind of like applesauce. It's not always a good idea to mix culinary textures with structural stuff, but just in order to give it some familiarity. So you can see the way that drips off. That is still way too thin. I'm going to add a little bit more Flox. I'm going to get the end of our cup, and I'm going to add some more Flox and stir that in. And I can see it's now just starting to thicken up. Okay, you can see that's still way too thin for a good bonding paste. And here we've mixed a bunch more Flox into our mix, and you can see it's starting to look pretty good. It's not moving much. It moves a little bit, but I think we can probably go with this. Actually, I think I'll add a touch of cabocil just to thicken it up so it doesn't sag out of place when we glue our parts together. Our epoxy bonding paste is almost thick enough, but I'm going to add a little bit of cabocil, fumed silica, to give it what we call thixotropicity, which is the capacity to stick to a vertical surface without running or sagging. You notice I'm wearing a particulate mask. That's because cabocil is nasty stuff. It causes silicosis like miners had in the turn of the century. So I've got this mask on to protect myself from the cabocil. I'm going to add just a little bit of this. It doesn't take much. We generally don't use any more than about 1 part cabocil per 3 parts Flox when we make bonding paste like this. Now when we mix this in, notice that it kind of drifts up into the air. You got to be careful about that. Now our paste is getting nice and thick. And, oh, take a look at that. See that? It's not moving at all. It's staying perfectly still on a vertical surface, but you can still see that it's kind of wet. And that's nice. That means it'll wet the surface of your parts pretty effectively. So I think this bonding paste is ready to go. What we're doing now is bonding in this lower hinge saddle into this left side rudder skin. Step one of this bonding operation is to use neat, that is unthickened epoxy resin, to prime the mating surface of this part and also to prime the mating surface of that part to give a good bonding surface for the bonding resin that we're going to apply in a minute. For this, we don't have to do anything more than get the surface wet with epoxy, and we can see where the resin wets out the sanded surface and starts to make it shiny. I'm going to stop there at that black line because that's the end of that's where the other side bonds on. And you don't have to use any more of this than absolutely necessary. I find a scrubbing type of motion works really well for this. Okay, so I've scrubbed the primer into that part, and I'm going to set that aside there, and I'm going to use a little bit more of my neat resin, and I'm going to prime the mating surface here. Notice that I've sanded that with 60 grit sandpaper to give it a nice rough finish. And also notice that I've marked out the bonding area with, I've marked out the bonding area with a black Sharpie so I know where to prime and where to not bother prime, to help keep me from applying too much primer and too much weight and wasting epoxy. Alright, notice I use the scrubbing motion to work the primer into the texture left by the sandpaper. And I look closely and okay, I think that's just about good and primed. Okay, I've sanded the bonding surface here and on this part that I'm bonding in. I've also acetoned it to remove the greases and waxes and contaminants. And then I applied neat epoxy resin to both surfaces to prime them. Now I'm going to apply our bonding paste that's actually going to glue the parts together. Sometimes we use cake icing bags to apply the bonding paste, but for a small job like this, I'm just going to use my acid brush and brush the bonding paste on. And there's no particular art to it. You just look for a nice kind of line of this stuff, and you sort of learn by doing a bunch of these things how much to use. And so I'm just going to use my judgment, and if it doesn't work out, well, we can always add more. We can always take it apart and add more bonding paste and put it back together again. This job's not over until the epoxy is cured, and that's a few hours away. All right. Okay. Kind of spreading it out, but also leaving a nice high lump in the center. It's nice to have to pile the bonding paste high and not, rather than spread it wide. That ensures that even where you haven't applied enough, you've at least got a bonding contact between the two parts. And also that high part helps, when it contacts, it helps force the air out from between the two parts so that you don't get air bubbles trapped in the bond line that reduce the bond area. I'm going to add a little bit more to this area here, and then I think we're about ready to go for this. Okay, what I'm going to do is press this into place in the marked location, and you can see there and there, whoa, I split my glove. Rule 0, time to down tools and change gloves.
Action.
I'm going to take this part, treated with the bonding paste. I'm going to press it into here, and as you notice, there's a hole there and a hole there. I'm going to use these plecos in those holes to clamp these two parts together. Clecos are temporary fasteners normally used when you're making like metal airplanes and stuff like that with rivets, but we found they're also very handy for holding parts together when we make composite sailplanes. So I'm going to sort of look at where it goes and look at that. I'm actually going to add a little bit more paste right there because I've made a couple of these and it sometimes takes a little bit more bonding paste there at the bottom of the rudder. And if it turns out a little bit shy, we can always mash some more in there, and it's a nice thick mix. It's staying where we put it. So, looks like enough. I'm going to press this into place, and I can feel the hydrostatic pressure of the bonding paste resisting the force that I'm applying. Oh yeah! Look at that squeeze out. That tells us we've got a nice full bond line, and we've got plenty of epoxy to glue this thing together and for a nice high-strength bond. Alright, now I'm going to sneak under here and see if I can get this Cleco through both the hole in the skin and the part. See the Cleco come up through there? And then I release the pliers and the Cleco clamps down. And you can see my other Cleco hole is all filled up with epoxy. I've taken the precaution of dipping the ends of my Clecos in wax, the same type of wax we use for mold release, and then wiping away the excess. That wax makes sure that the epoxy doesn't stick inside the Cleco and ruin it. So now I'm going to chase through this hole, see if I can get Mr. Cleco to line up, and it's often a little bit of a challenge. Oh, and it's being a real challenge today. There we go. There we go. And now our two parts are Clecoed together. I'm going to go get a stick, and we're going to wipe up some of that squeeze out. Okay, notice that I'm leaving a little bit of a fillet there. You don't want to take too much of the bonding paste away. We avoid using brushes for this because a brush will tend to get between the two parts. The bristles will get between the two parts and actually sweep some of the bonding paste out, and we don't really want that. Okay. I'm going to treat this face here, scrape away the extra bonding paste, and then sweep this one away here. And you can see I'm collecting a little bit of bonding paste on this cup here. There we go. There we go. And sweep it out from there and sweep a little away from here. Alright, that's the lower hinge saddle all bonded in and ready to cure. We'll come back in a little while and we'll glue in the upper hinge saddle. We're making gliders here. Alright. So I'm about to apply neat resin here so we can bond in the upper hinge saddle for our HP-24 rudder. And by the way, if these parts look a little bit irregular, it's because these are development parts that we use to validate the tooling. They're not necessarily flight parts, so if they look a little bit funky, don't worry. The ones in your kit are going to look really nice. And they do look really nice. Okay, so let's get some neat resin on here. Once again, we just sort of kind of scrub it in there. It doesn't take any more than is absolutely required to prime the surface and make it shiny. And again, we've sanded this and we've acetoned it to take away the solvents, or no, to take away like the contaminants like wax. All right, which way does that go? I'll put it in the right way up. It goes like, that's the top, the part with the hole in it, that's the top. That's the top of the rudder there, so I'm gonna prime this part here. You can see I've sanded it to take all the shiny away. Shiny's bad. Shiny doesn't stick. Unless it's the neat resin. But you can tell the difference between like a shiny part and shiny neat resin. Alright. That guy's all nice and primed. Alright, I'm going to set that there. And again, our epoxy bonding paste, epoxy resin thickened with Flox and cabocil. I'm just going to take a carefully calibrated by eye chunk of it and start brushing it on here. Looking for the hilltop right in the middle of the bond line so that when I mash them together it forces the air out and doesn't collect air bubbles inside the bond line. Alright, let me show you this. Got nice thick bonding paste there, and you can see that the cabocil has got it mixed, got it nice and thickened up so it doesn't sag down. I'm going to clean this bond line up just a little bit more, mash these two parts together, and then put clecos in. Airplane type clecos like all the Dick Van Grunson RV series builders use. We love them. We just got to wax them so that the epoxy doesn't ruin the darn things. I got a whole bucket full of dead clecos that I forgot to wax. Alright, so I got my black line there that I marked onto the part to tell me exactly where to put it. And I mash it into place. Oh, look at that squeeze out. Squeeze out's good. Squeeze out helps you know that you absolutely have enough epoxy. Where you don't get squeeze out, you have to wonder, did I really put enough in there? So if you don't get squeeze out, consider disassembling it and checking it again. And at very least, look deep into your part and make sure you actually do have enough epoxy in there. Alright, now I gotta figure out, now I gotta find this cleco hole in both parts. Kinda gotta fish around a little bit. Sometimes I'll use an ice pick. Nope, I missed it. Get that cleco out. I can feel my part moving around. Squeeze it back into position and try again. I got plenty of epoxy there, so I'm not really worried that I've squeezed some out. Okay, I gotta stand down and get the ice pick to find the cleco hole.
Okay, action.
Okay, I'm back. Got myself an ice pick. This is actually a scratch-all. We use it to mark, to scribe lines on bits of material, so we know where to do cuts and stuff like that. I'm gonna mash it up through the cleco hole, make sure I've got... Okay, I'm pretty sure that's in position. I've mated it together. Let's make sure that that's the ice pick coming through. I believe it is. So I'm gonna very carefully pull that and see if I can get Mr. Cleco up through that hole. There he is. There's Mr. Cleco. Now I take this other cleco, and with the first one in, the position of the second one is much more determinate, I guess you'd say. Alright, there we go. We got a bunch of squeeze out, and I've also kind of mixed it out of position, so I'm going to kind of make a little fillet there using my mixing stick. And you can see I'm squeezing some out. And I notice I've got a little bit of a dry zone here, so I'm going to mash a little bit of filler into that area where I think I might have been a little bit shy. And I'm going to very carefully with my stick sweep away. And again, we use the sticks and not a brush because the bristles of the brush will actually get into the interface of the bond and sweep out some of the resin we want to leave inside. And I'll pick this up and I'll show you what it looks like on the inside. I'm going to come around. And there's our upper saddle bonded into place. That thing's good. That's where the hinge point goes at the upper end of the rudder. And there's our lower saddle. All schmoed together with bonding paste and ready to cure. I was just doing a final alignment check on our rudder skin. I was sighting down it, and I noticed that it's not perfectly straight when I sight it from here down that flange to this point here. So in order to make sure it cures perfectly straight, even though we've cut these notches out and glued in these new parts, these parts haven't cured yet. So I'm going to clamp this to a piece of aluminum tubing, and that'll help ensure that the part cures perfectly straight, so it'll fit well with the glider when we go to assemble it. I'm just going to put this aluminum tube here, and then clamp it there, and then clamp it here. And you notice that it's actually hanging kind of low there. Clamp it there. Bring that up into alignment. Now when I sight down the flange, the stick is holding it perfectly straight.